Hey everyone, today we are having a look at Leetcode question number 3833. In this question, we are given an integer array nums of length n and we need to determine the number of dominant indices in the array. So, an index I is dominant if the value of that index is greater than the average of all the numbers to the right side of it. Basically, nums I value is greater than average of everything to the right, and our task is to count the number of indices that are dominant. An average is calculated by adding all the numbers and dividing it by total number of elements. Also, we are given that the rightmost or the last element can never be dominant because there is no element on its right. Coming to an example, we are given a nums with elements 5, 4 and 3. So for index 0, the average of the numbers to the right is 4 plus 3 by 2, which is 3.5. And since 5 is greater than 3.5, this is dominant. Coming to index 1, the value to the right side of it is 3. So the average 3 by 1 makes it 1. And since 4 is greater than 3, this 2 is dominant. And the last number can never be dominant. Hence we return the output as 2. For this example, we have elements 4, 1 and 2. So for the 0th index, the average of elements to the right is 3 by 2, which is 1.5. And since 4 is greater than 1.5, this is dominant. For index 1, the average to the right is 2 by 1, which is 2. And since the value at index 1 is not greater than the average, it is not a dominant number. The value at index 2 can never be dominant since it's the last number. Hence we return the output as 1. Now the solution that comes to us immediately is the brute force one, that for each index we calculate the sum of all elements to the right and then compute the average. But doing this each time for every element requires a nested loop, and hence the time complexity becomes O of n square, which is too slow. So we need something better. To optimize this, we move through the array, but instead of recalculating the same sum again and again, we store a running sum of the right elements. In this way, each element is processed only once and the total complexity becomes O of n. For example, if we have an array with the numbers 3, 2, 4 and 1, the 0th index, first index, second index, third and n minus 1. As the leftmost number can never be a dominant one, we start our I from the n minus 2th position. To calculate the number of elements to the right side, we simply subtract n minus 1 and I. This gives us all the elements after I. So we begin from n minus 2 and we move backwards slowly till we reach the 0th element. We start with sum being 0 initially and we keep on adding every element, thus calculating the sum simultaneously as we are moving throughout the array. We keep a count of the number of dominant indices. Starting our I from n minus 2, we add the I plus 1 with value to the sum, which is 1. The average is calculated as 1 by 1, and since nums I 4 is greater than the average, this is a dominant number. We increment the count by 1. We then iterate our I to the next element. We add the I plus 1 value to the previously calculated sum. The new average becomes sum upon total number. Since the value at I is less than the average, this is not a dominant one. Hence, we move on to the next element. We increment the I plus 1 value in our sum. Our new average becomes 7 by 3, which is 2.33. And since I value 3 is greater than the average, this is a dominant number, and hence our count increments to 2. Since we have reached the end of array, we return back count as our answer. Having a look at the code, we have sum set to 0, answer initialized to 0, and n, which is the length of the array. We begin our loop from n minus 2th position till 0, decrementing each time. We add the I plus 1 every time in the sum and check if the value at ith position is greater than the average. If yes, we increment the answer or the count, and once we traverse the entire array, we return back our answer. One common mistake people do here is writing this condition incorrectly. Mostly tend to write this as sum divided by n minus I minus 1. Java interprets this as sum divided by n minus I minus 1, which would give us a completely wrong answer. Hence we need to take care of the brackets. The correct logic being sum divided by bracket n minus I minus 1. The time complexity of this solution is O by n. And since we must read every element at least twice, On is the best possible complexity. The space complexity is O of 1. So this was a technique which belongs to suffix-sum optimization. I hope I was able to explain the concept in a properly structured manner. For any suggestions or feedbacks, do comment below. Thank you.